Welcome to the video for Lecture 8, Section 1 for BBE 4023. In this video, we will cover how transfer functions are related to the closed-loop process control. This is the general block diagram of a closed-loop control system. By the end of the semester, we will replace this diagram with a single overall transfer function that relates the set point and manipulated input to the process output. During this lecture series, we will begin to show how we replace the four blocks with individual transfer functions, and we will be able to combine and solve them using Laplace transform and MATLAB. This slide shows the same closed-loop process control block diagram with transfer functions in the four blocks of interest. The transfer functions are given by G1s, G2s, G3s, and Hs. Each block has an input and an output. The transfer function describes how the time-dependent input is transformed into the output in mathematical terms. This slide shows the different forms and definitions of transfer functions that we have used. It is the output function over the input function, and it is the input function entering a block diagram where the transfer function produces the process output. Or in equation form, the output ys equals the transfer function gs times the input function xs. This slide summarizes the key characteristics of transfer functions. First, they are Laplace domain expressions that relate the process output to the input. Second, transfer functions are a property of the system or process. Transfer functions depend on the differential equations that describe the physical processes, but they are independent of the input function. Third, they come from the physical process and the units relating the process inputs to the output. But if given a transfer function without other information, we cannot work backwards to find the physical structure of the system. So if you are simply given a transfer function, you cannot work backwards to figure out the system or process itself. Fourth, transfer functions describe the dynamic system characteristics and performance. Fifth, because we can change the input function and change other characteristics of transfer functions fairly easily, they are used commonly to study the system response to various inputs and process settings. As we have mentioned earlier, by the end of the semester, you will be able to combine all of the transfer functions for the different closed-loop process control elements, including controller, actuator, process, and sensor feedback elements, and produce a single overall transfer function. This overall transfer function will be able to take different input functions and tell user how dynamic process output will change. And if all I gave you is the transfer function, you can study the process, but you will not be able to work backwards and figure out the original physical process if I don't give you more information. So the key points from this video are that transfer functions describe physical dynamic processes. They relate the input and the output functions. And we will usually use them to see how the process output responds to a given input function. Finally, the transfer functions can be used to study the process response. This brings us to the end of Lecture 8, Section 1 video on how transfer functions are related to closed-loop process control. Please write down any questions you might have and bring them up in class or lab.